lecture 6. Lecture 6. Don't forget, we are in part 1. You see? GR, definition and properties related to the Cartesian coordinates, classical mechanics and electromagnetism. Lecture 6. Now I will expand the cross product, that's the cross product, okay, in terms of the components. Okay. I want to prove, I want to show that C sub I, see, is epsilon ijk, ajbk, where the permutation symbol, the Levi-Civita symbol, is defined like that. Plus 1 even permutation, minus 1 odd permutation, and 0 equal indices. Now, in general, in the literature, we call C sub I as a vector. Actually, it's not a vector. This is a vector component. See? C is a vector. Ci is just component. But, as I said, that in general they call one free index. C sub I is a free index. Attention, the number of free index on the left-hand side must be the same number on the right-hand side. I is free, I is free. J is dummy, K is dummy. You see? That you call vector. Now, I want to prove like this way. But before I will show you, just using this notation over here, okay, that from the definition of cross product, consider, see? Now, E1 cross E2, you see? E1 cross E2, you just move, imagine moving E1 towards E2, then will be a rotation will be E3. This is equal E3. And don't forget that they are orthonormal basis. Okay? Here I can summarize delta ij is equal ei dot ej. You see? I put a dot over here. You see the scalar product, delta ij. So this will be 1 when I is equal j. It will be 0, okay, otherwise. Now, look how interesting. E1 cross E is equal E3. Obviously, if I have E2, that's right, cross E1 minus V3. Just look at here. E2, E2 cross E1. You see, E2 cross E1. I rotate E2 to reach E1, so I have minus. And this happened with the other unit vectors. Okay. Now, let's expand. Expand Ci. Let's put the A cross B. This is equal AI EI. Look how simple. These are dummy. You see? These are dummy. There will be A1, E1 plus A2. Instead of write in the long row line, I just put here. You see? This simple way. Cross BJ EJ. See? Now, what is important here, I just write down, this is a vector C, okay? Don't forget. This will be EA, BG, I don't need that. EI cross EJ. See? Now, and this over here is just EK. See? This here will be AI, BJ, EK. See? Because EI cross EJ, let's put here. You see, EI cross EJ is EK. In this case, I is equal 1 and J is equal 2. Okay, in this case. But what is important? So you see, look at here. This is a vector C. This is a vector. So vector equal to vector. Now, if I expand this, I will have this case. I'll put over here, okay? I will expand this, okay? This is equal. This will be A1, E1, plus A2, E2 plus A3, E3 cross B1, I'll put here, cross B1, E1 plus B2, E2 plus B3, V3. See? It's important here for you to know that E1 cross E1 is equal E2 cross E2 is equal E3 cross V3 is equal to 0. Why? Why? Because the definition, okay, for instance, of A cross B is equal to C. This over here is equal AB sine of alpha. Alpha is the angle between A and B. From the previous video, okay? So, if I have a vector here, A, if I have a vector here, B, see, the angle here will be 0. So, sine of 0 will be 0. Or also, if I have the opposite direction, the angle will be pi. Sine of pi is 0. So then when the direction coincide, you see, between two vectors, the cross product will be the vector 0. Okay, it's quite clear. Now, if I develop, expand, say, knowing this here, okay, this leads to as follows. I expand this, okay, and using, okay, the adequate to be consistent, okay, with the definition of the cross vector between orthonormal bases. Now, if I write this, I can come up, let's write here, A cross B is equal. Now, I write this in this form. E1, E2, E3. This is A1, A2, E3. B1, B2, B3. You see? Why do I know that? By inspection. There is no demonstration. And also, what is this is determinant. Determinant. Okay. This now you know from the